For today's lesson, we're going to revisit distance and midpoints. So let's start with distance. If I give you a graph, and I give you 2 points and I connect them with a segment, and if I ask you for the distance between points G and H, that's the exact same thing as if I said, find the length of segment GH. So finding the distance between 2 points or the length of the segment is the same thing. So if you see problems worded one way or the other, they mean the same thing. So basically we want to know how long is this segment. So there's 2 ways you can approach it. From a graph, it's probably easier to use the Pythagorean theorem. And so what we want to do is make a right triangle. So following grid lines to get from one point to the other. There's our right triangle. And then we count how long is each side. So 1, 2, 3, 4, 5, 6, 7. This side is 8 units long. 1, 2, 3, 4, 5, 6. And this side is 6 units long. In the Pythagorean theorem, if we'll call this side C for the hypotenuse, that's the longest side, the one across from the right angle. The one that's across from the right angle is angle C. Is side C. So the Pythagorean theorem said that in a right triangle, if the 2 legs are called A and B and the hypotenuse is C, A squared plus B squared will equal C squared every time, as long as it's a right triangle. And so we can use that in this case, and it doesn't matter which side we call A or B. We can flip-flop those. So I'm going to say 6 squared plus 8 squared equals C squared. 6 squared, remember, means 6 times 6, not 6 times 2. And 8 squared means 8 times 8. So that's going to be 36 plus 64 equals C squared. And when I add those, I get 100 equals C squared. So I'm looking for a number. When I square it, I get 100. There's actually 2 answers. C could equal 10, because 10 times 10 is 100. C could also equal negative 10, because negative 10 times negative 10 is 100, positive 100. But in terms of what we're looking at, C is the length of a segment, so you would never have a negative length. But anyhow, it doesn't always work out to be a nice number like this, so what we'll do is in every case you take the square root, the positive root of the number. So the square root of 100 is 10. And since I know C is a positive value, I can just say the square root of C squared is C. Now, C was just something I used to help me out with the problem. What I really mean is that the distance from G to H, or H to G, is equal to 10 units. And so that's the distance between those 2 points. So that's how we do it using the Pythagorean theorem. What if we didn't have a graph? What if we just had the coordinates? Well, in that case, we would want to use what's called the distance formula. And the way that works is if you have 2 points, and let's call these points x sub 1, y sub 1, and the other point we'll call x sub 2, y sub 2. So the distance between the 2 points is going to equal a giant square root, 2 sets of parentheses. Each of those are squared and then added together. And inside the parentheses, we're going to subtract. What are we going to subtract? We're going to subtract whatever the x numbers were. And then in the other parentheses, we're going to subtract whatever the y numbers are. Maybe I'll change my color coding on this. There we go. So whatever coordinates they give you for the 2 points, you plug those in where I wrote x sub 1, x sub 2, y sub 1, y sub 2. So let's do an example with that. I've already talked about that. So here, let's take this and let me make a copy of this. Let's just clone it, bring it down here. And so it's a good idea to have this written somewhere and always write it in the problem off to the side so you know what you're following. All right, so here's 2 points. We want to find the length of AB, the segment connecting them. So this one is my x sub 1, and this is my y sub 1. And this one is the x sub 2, y sub 2. So I'm just going to plug it right into the formula. The length of AB, which I use for the notation, just AB with no bar over the top. That means the distance between those. I make a giant square root, 2 sets of parentheses. Each of them is squared, added together, and inside we're going to subtract. And what are we subtracting? Our numbers. So the first x number was 7, and the second one was 2. I got those from there and there. And then in the next parentheses, I'm going to subtract the y numbers. So I have a -4 and a -8. Now it's important here to understand that we're subtracting, and now we're subtracting a negative this time, so minus a negative is really a positive, so that's just going to become a plus. All right, and if you're struggling with these calculations, you can always punch this exactly as is in the calculator in one shot, and you'll get your answer. I'll show what I mean in a minute. But if you want to work out each piece individually, 7 minus 2 is 5. -4 minus a -8 is -4 plus 8 is a 4. And then 5 to the second power, 5 times 5 is 25. 4 to the second power, 4 times 4 is 16. You should always get 2 positive numbers after you square that. And so we get the square root of 41. Now, that's not a perfect square. If I use my calculator, it's going to be about 6 point something. So I can grab a calculator and take a look at that and see what we get. Let's do the square root of 41. 6.403. So I'm going to say 6.4. And notice I use a little wavy equal sign for approximately equal to. So the exact answer you could just leave as the square root of 41. And that's it. If you get a number like the square root of 100, you should write 10. Or if it was the square root of 25, you would write 5. Now, one more thing before we go away from this. I mentioned you could have just punched in the exact problem as is. So I could have punched in 7 minus 2, close parenthesis, squared, plus another parenthesis, -4 minus a -8, close parenthesis, squared. And there's that 6.403 number again. It won't give you the exact answer and say the square root of 41, but it'll give you the decimal for that. All right, so the first part of the homework is on the worksheet called distance, and I just want you to do the even numbered problems, 2, 4, 6, 8. So don't do the odd numbered problems. All right, now let's take a look at midpoints. So there's 2 ways you can do this as well. If we start with a segment on a graph and we have to find the midpoint, well, all we need to do is count. So if you remember, we just got done making a right triangle to figure out for the Pythagorean theorem. Same idea here. So if I count 1, 2, 3, 4, 5, 6, 7, 8 units and then 6 units, if I want to go to the middle of this segment, that means I want to go halfway. So what I'm going to do is go half of 8, which would be 1, 2, 3, 4, and then half of 6, 1, 2, 3. And there's my midpoint. And if they want me to give the coordinates of the midpoint, well, from 0, 0, that would be -1, -2, -3, 1, 2, 3, 4, 5. So -3, +5. And that's all you have to do. There's your midpoint. Easy enough. Now, what if we don't have a graph? What if we don't have a graph? Well, then we have a formula we can use called the midpoint formula. Same idea here. Let's say our 2 points are x sub 1, y sub 1, and x sub 2, y sub 2. Our midpoint formula is going to be the average. Now remember, here we're getting an actual point. When we did the distance formula, we got one number. Here we're going to get a point. So points are listed in parentheses with 2 numbers and a comma in between them. And to get the midpoint, we are just going to average the x numbers and average the y numbers. So when you want an average, you add them up, divide by 2. So I'm just going to plug in the x numbers for the first spot and the y numbers for the second spot. So notice here, let me draw an arrow. Notice here we're adding the x numbers and we're adding the y numbers. For the distance formula, we subtracted them. Here we're adding them. And that's all you do. So let's try an example here. Here's our 2 points. So this is going to be my x sub 1, y sub 1, and this is my x sub 2, y sub 2. And to get my midpoint, we'll abbreviate midpoint, I'm going to get 2 answers, put them in parentheses as an ordered pair. I'm going to average them, so I'm going to add them up, divide by 2, and then I'm going to plug in the numbers. So my x numbers were 7 and 1, and my y numbers were -4 and +5. So all I'm going to do is add those up. 7 plus 1 is 8, and then divide that by 2. You'll get 4. -4 plus 5 is 1, and then you divide that by 2, and it doesn't divide evenly, so leave it. Just 1 divided by 2. You can leave it as a fraction, or we could leave it as a decimal if you divided it on your calculator. Either one would be fine, decimals or fractions. So the second part of the homework is going to be the midpoints worksheet, and on this one I want you to do the odd numbered problems. So just do 1, 3, 5, 7, 9. So on the distance it's evens, and on the midpoints it's odds.